Assalamualaikum and hello. For today's lesson, we are going to look at how we can generate the selection sets for LL1 grammar. Like we have established before in our syllabus, there are three types of grammar: simple grammar, quasi-simple grammar, and LL1 grammar. We have learned how to generate the selection sets for both simple and quasi-simple grammar previously. Now we are looking at LL1 grammar, which is the type of grammar used for compiler generation. The grammar we are using comes from our textbook, page 116. This is the grammar. As you can see, it is not quasi-simple and definitely not a simple grammar. How do we know this? Because after the derivation arrow in step 1, we can see a non-terminal. However, we cannot definitely say that this is an LL1 grammar because we still need to check for the rules that are defined by the same non-terminal on the left side of the derivation arrow, whether their selection sets overlap or not. The same condition for simple and quasi-simple grammar. For example, in Rule 2 and Rule 3 here, they are both defined by the same non-terminal A. Therefore, their selection sets should not overlap. As for the steps that we need to take, there are 12 steps. These come from your textbook starting with page 116. However, I have made a simplified graph of these 12 steps here. And this basically will be the guide that we will use in this lesson. Okay, let's go to the first step. The first step is to find nullable rules and nullable non-terminals of the grammar. Nullable means it can be derived to empty, or in this case, to epsilon. Therefore, nullable rules are rules that are derived to epsilon. In this grammar, the obvious nullable rule is Rule 3. Nullable non-terminal, meanwhile, are the non-terminals on the left side of the derivation arrow of the nullable rules. For Rule 3, it is A. Therefore, we can list out that the nullable rule is Rule 3 and the nullable non-terminal is A. So I'm going to type that out. So our nullable rule is Rule 3 and our nullable non-terminal is A. Okay. However, there can be non-obvious nullable rules. For example, if there exists a rule that looks like this. Imagine if we have the fifth rule and it says B can be derived to A. So nullable non-terminals are basically non-terminals that can be derived to empty. So it is like we can cancel the non-terminal out. So imagine if we have this rule 5 over here and we cancel A out, it is like B also can be derived to epsilon. Therefore, we should include Rule 5 as a nullable rule and B is also a nullable non-terminal. But of course, in this particular grammar, we do not have Rule 5, but this is a condition that you have to remember. Okay, the second step is begins directly with or BDW. So this is the second step. To generate this step, we need to refer to step 1. So as you can see, there is an arrow coming in to BDW from step 1. Whenever we have to refer to step 1, it means we need to consider the nullable non-terminal. So again, our nullable non-terminal is A. Okay, for this step, in order for us to generate BDW, what you need to do is we take a look at each of the rules and derive what does the non-terminal on the left side of the arrow begins directly with. So, we are going to look at the rules one by one. S begins directly with A. So, I'm going to type that out. So, we have S begins directly with A, and then we also have A begins directly with B. A begins directly with small letter B, and then we also have B begins directly with C. So basically this is how you derive the BDW relations. I think you get the pattern over here. But remember, for step 2, we need to consider nullable non-terminal because we have an arrow coming in from step 1 over here. So again, nullable non-terminals are terminals that can be derived to empty, so it's like we can cancel it out. So if I cancel A over here, A still begins directly with B, and we already have it over here. But however, if we cancel A over here, S can now also begins directly with capital B. Therefore, we need to include in our list of BDW S, BDW, capital B. I hope that is clear to you guys. Okay, once we are done with BDW, we can move to the next step, which is BW. So, BW is actually a reflexive transitive closure of the second step. That is why if you look at our graph over here, the arrow coming in from step 2 has a star on top of it. This signifies that we need to do a reflexive transitive closure operation. Okay, so let's start with the first condition. So let me try BW over here. So in order for us to generate a reflexive transitive closure operation, first all that is inside BDW should be in BW. So I'm just going to type it out. S BW A BW small letter B, B BW small letter C, and S BW capital B. The second property is the transitive property. So again, because we have S BW A and then we have A BW B, therefore what should we have? In the transitive property, we will have S BW small letter b. Okay, same goes to this. We have S BW B and then B BW C, therefore we should have S BW small letter C. So that is the transitive property. And finally, for the third property, for all symbols in the list, the reflective pair should be added. So I'm going to add S BW S, B BW B, A BW A. So make it a habit to list out the non-terminals first before you proceed to the terminals. We should also have B small letter B, BW small letter B, small letter C, BW small letter C. Okay. For the reflexive property in BW, we should also include, so if you look at our graph over here, there is a symbol saying plus T. This is plus terminal. It means in the reflexive property of BW, in addition to everything that comes from BDW, you should also include all terminals in this grammar. So again, in our grammar, our terminals are lowercase c and lowercase b. But because both of these are already inside our reflexive property, we do not need to include that. But for example, if we have something like this in the fourth rule, if we have B can be derived to CD, we would not have D in our BDW because B cannot begin directly with lowercase d. So if that happens, we need to include DBW lowercase d in our BW list. But as currently our grammar doesn't look like that, but this is something that you have to remember. Okay, so we are done with the first step, second step, and third step. Let's move to the fourth step. The fourth step is the first of all symbols. So remember, whenever we are using Roman numeral, it means symbol, and symbol means both non-terminals and terminals. So for this step, we would be using the steps that we have generated from step 3. The list that we have generated from step 3, because you can see there is an arrow coming in from step 3 over here. Okay, so always make it a habit to start with non-terminals, especially the starting non-terminals. So we are starting with S. To do this step for S, look at the list of BW from step 3 and find S on the left side. So I'm going to start with S. I'm going to look at the left side and I will choose out only S. So I have this one and this one, and this one. So we have 5 pairs defining S. And then we need to look on the right side and only choose out terminals. So out of these 5, only these 2 ends with terminals. Therefore, because these two, SBW lowercase b and SBW lowercase c, fulfills this condition, we can add that the first of S is a set that has B and C. So this is how we derive the first of S. So let's continue with the other symbols. So after S, I'm going to do A. Okay, first we choose A on the left side, and then from these two, only choose the one that ends with terminal. So it's only this one. Therefore, first A is lowercase b, and then first B. Same step that we did. So these are the 2 pairs that have B on the left side, but only this one has terminal on the right side. Therefore, first B is C. Okay, after all the non-terminals, we can proceed with terminal. First B is B, and first C is C. So same step, we choose the one that has B on the left side, on terminal on the right side, C on the left side, and terminal on the right side. So now we have generated the first of all symbols. After this is done, we can move to the next step, which is to find the first of the right side of each row. So to generate the list for step 5, we need to refer to the pairs generated in step 4 and also refer to step 1, because you can see there is an arrow coming in here from step 1. Again, remember, whenever we are referring to step 1, it means we need to consider the nullable non-terminal. So how do we generate, or how do we extract out the information for step 5? So it is generated by looking at the right side of each rule. So this is our rules. The right side after the derivation arrow are this one. So we're going to do this one by one. Okay, first A, B, C is, okay, to do that, remember we need to look at step 4. First ABC is the first for the symbol that you see, the first symbol. So the first symbol is A. Therefore, first ABC equals to first A, which means it is, as we have generated in step 4, it is B. Okay, and then first BA, so the first symbol over here is lowercase b, and from step 4 we know that first B is B. Sorry, this is uppercase B. Okay, next, first epsilon. First epsilon is nothing, it's an empty set. So I'm just going to write an empty set. And finally, first C equals to C, as what we get from step 4. But remember, we need to consider nullable non-terminal. So for step 4, we need to consider nullable non-terminal. And again, having a nullable non-terminal, it is like you can cancel the non-terminal out. So if we cancel A out, the first symbol for rule 1 now is also B. So you need to do something to this. First A union with first B, because B can also be the first symbol for first rule, which means it is now not only B, because first B, if you look at our step 4 over here, is C. Now it becomes B, C. Okay, so that is for step 5. We have generated the first for all the rules. So if we have 4 rules, you should have 4 over here. First ABC, first BA, first epsilon, and first C. Okay, if your grammar do not have a nullable rule, after step 5, you can actually jump direct to step 12 if you do not have a nullable rule. But because we have a nullable rule over here, we cannot do that. So we need to go to step 6. Okay, so how do we generate step 6? To generate step 6, we are generating the property of FDP, which is the short form for followed directly by. In order to do that, we are only considering the right side of the derivation arrow. So this is the right side of the derivation arrow. We are not considering anything on the left. And we are also only considering non-terminals. So what are our non-terminals? Our non-terminals are this A, B, and A. Okay. So to generate the FDB relation, we look at this non-terminal. Remember 1, 2, 3. A is followed directly by B. So I'm going to write that out. A is followed directly by B. Next, B is followed directly by C. So I will type that out. B is followed directly by C. And the final one, A is not followed directly by anything because it is the end of the string. Therefore, for FDB, we only have 2 lists. Okay, so we are done with FDB. Now let's move to the 7th step. So the 7th step is called DEO. And DEO stands for direct and off. So if you look at our graph over here, DEO and BDW has a lot of similarities. So first of all, both are shaded with the same shade of blue. And then both have arrows inside. So we have arrows. But if the arrows of BDW goes from left to right, the arrow of DEO goes from right to left. So this basically signifies how you are going to read out DEO. So how do we do that? To read out DEO, we're going to do it row by row. So let's start with the first row. C is direct and off S. Okay, so it has similarity with BDW. BDW, we are reading it from left to the right as BDWA, but for DEO we are reading from right to left, CDEOS. So I'm going to list out the first property or the first list, CDEOS. Okay, next, what do we have? We can also have ADEO A, and we can also have CDEO B. So let me list that out. ADEO A, CDEO B, but for step 7, you should also consider nullable non-terminal because we have an arrow coming in from step 1. So again, class, if we have to consider nullable non-terminal, what we are doing is we try to cancel out our nullable non-terminal from the grammar. So if we are cancelling A over here, something happens to step 2, or sorry, rule 2. We can also have B DEOA. So I'm going to add into our step 7, B DEOA. Okay, so we are done with step 8. Next, let's move on to we are done with step 7. So now let's move on to step 8, but let me move this thing first. Okay, step 8 is EO. EO has lots of similarities with BW in the sense that it is actually a reflexive transitive closure of DEO. So if you look here, it has similarities to BW. Both have arrows coming in from the prior step and both has star on top of the arrows. If BW is the reflexive transitive closure of BDW, EO is actually the reflexive transitive closure of DEO. So, but if you look at the symbols here, for BW, we need to consider all terminals in the transitive property, in the reflexive property. For EO, we are actually including all non-terminals in the reflexive property. But let's start one by one. So everything in DEO should be inside EO. So I'm going to write it down again. CEOS, AEOA, CEOB, BEOA. Okay, let's check whether we have a transitive property. It looks like we do not have a transitive property. So how about the reflexive property? So let's make it a habit to start with all the non-terminals first. S, E, O, S. Okay, because we already have A, E, O, A over here, we do not need to list it out again. So I'm going to proceed with B, E, O, B, and then B, lowercase b, E, O, lowercase b. This one over here, this one should be small letter, is it? Yes, this should be small letter. Sorry, because of the autocorrect, we became confused a little bit. Okay, so C, E, O, C. So this is the list for our EO. So how do we consider all nullable non-terminal? Sorry, not nullable non-terminal, all non-terminals. So where are all of our non-terminals? A, B. But because we already have A, E, O, A over here and B, E, O, B over here, so we do not need to add it again. Okay. So we are done from step 1 up until step 9. Now we are moving to the biggest step yet, which is step 9, FB. So step 9 is actually, when you want to generate it, you would need to consider 3 previous steps. So we will be considering step 3, step 8, and step 6. And there, if you look properly in this graph, there are numbers. So we have 1, 2, and 3. These numbers actually signify the position of where we should put the list generated from this step. So this means EO should be in position 1, FDB in position 2, BW in position 3. So I am going to start with FDB because it is in the middle. So what I'm going to do is I'm going to copy list generated from FDB and put it inside FB. So this is in position 2. Next, the one in position 1 is EO. You do not need to copy everything from EO. You just need to copy those that ends with A or B. So this is our EO. I'm just going to choose the one that ends with A and also B. So we have these 3. So I will just copy it up. A, E, O, A, and put it over here. And then B, E, O, A, and put it over here. And then B, E, O, B, and put it over here. Okay, next, the one in the third position is BW. Again, you do not need to copy everything. You just need to copy those that starts with B or lowercase c. So let's go and look at our BW. So this is our BW. I'm just going to choose those that starts with B and lowercase c. So let me copy those out and put it over here. And then CBW lowercase c. Okay, now that we have all of this, what do we do with it? So generating FP is like doing a long transitive operation. So because A, EOA, A, FDBB, and B, BWC, it means we have A, FB, lowercase c. Oh, what happens to the font? It's okay. It's okay. Next, because AEOA, AFDBB, and BBWB, it means AFB uppercase B. Next, BEOA, AFDBB, and BBWC, it means lowercase b, FBC. Then B, FB, uppercase B, and finally B, EOB, BFDBC, and CBWC, therefore lowercase c. So this is our FB relation. Next, step 10. For step 10, it is actually an extension of the FB relation. We are adding to our FB list generated in step 9. To do that, we are looking at step 8 and step 9. We are adding to those generated in step 9, and to generate step 10, we need to refer to step 8. So how do we do this? What we need to do is we look at EO, so where is our EO? So this is our EO. We choose those that have starting non-terminal on the left side. So because our starting non-terminal is S, so it is this one. And then we look at, sorry, okay, I'm a bit confused. Not S on the left side, S on the right side. So we look at S on the right side, and then terminals on the left side. So let me erase this. S on the right side. So we have this and this one. But terminal on the left side, which is only this one. This is non-terminals on the non-terminal on the left side. This is a terminal. So SEOS. Because SEOS, it means SFB and marker. B and marker. If you have something like A, EO, S, this would mean you can also have A, FB, and marker. But of course, we don't have it here. So the only pair generated for step 10 is SFB and marker. So this SFB and marker is included in the list that we have already generated in step 9. It's included in this. And then for step 11 is we need to find the follow set of our nullable non-terminal. So to do that, we need to refer to step 10 and step 1, because step 1 is using a nullable non-terminal. So our nullable non-terminal is A, which means we are trying to find the follow set of A. follow A. So in order to get follow A, we need to refer to FB. So FB has been generated in both step 9 and step 10. So what we do is we look at A on the left side. So we have this and this, and then we are only choosing terminal on the right side, so only this particular pair. So because A, F, B, lowercase c, it means follow set of A is C. Okay, so now we are done with step 11. We can move to the final step, which is step 12. I'm going to put it over here so that it's easier for us to see. So to generate step 12, we are looking at those already generated from step 5 and step 11 and step 1. So we're looking at 3 different previous steps. So first of all, we are just copying all that we have generated in step 5. So the selection set for rule 1 is first A, B, C, which is this thing over here, this set over here. Then the selection set for rule 2 is first BA, which is this. Next, this is where we are referring to step 1. The third rule is a nullable rule. So in order for us to get the selection set for the third rule, we need to union the first of epsilon with the follow set of A, because A is the non-terminal of our third rule. So to do that, it is first epsilon. So just imagine this E is epsilon. It's hard for me to go and copy the epsilon symbol. Union with follow A, which is for empty set, union with C, and it is actually C. And finally, for the selection set for rule 4 is first C, which is C. Okay, so basically step 6 up until step 11 is so that we can get the follow set of our nullable non-terminal, and so that we can union it with the first of epsilon. Okay, now we have found all the selection sets for all the rules, and then we can check, because rule 2 and rule 3, they are both defined by the same non-terminal A, but because rule 2 the selection set is B, and for rule 3 the selection set is C, these selection sets do not overlap, so we can conclude that this grammar is an LL1 grammar. Okay class, I hope that you can understand what the steps that we have discussed today. So I'll see you later. Thank you very much.